Planning the electrical for an outbuilding involves several key considerations. Firstly, let's look at the circuit layout. A common approach is to dedicate individual circuits to different loads. For example, you might have breaker 1 dedicated to the air compressor at 15 amps. Breaker 2 could serve the freezer outlet and an additional power outlet. And breaker 3 might handle the outside light, an 8-foot shop light, and additional power outlets. Regarding the main panel wiring, it is generally acceptable to move the service entrance feeders from a double pole breaker to the bus lugs. This provides a direct path from the main panel to the outbuilding. However, always de-energize the panel before making any changes and consult with a qualified electrician if you are not comfortable working with electrical panels. Now let's discuss conductor sizing. The appropriate conductor size for the circuit to the outbuilding depends on several factors, including the distance to the outbuilding and the total amperage draw of the circuit. Since the air compressor typically draws the most amperage, it's crucial to size the conductors accordingly. To ensure compliance with the National Electrical Code (NEC) and safe operation, it is highly recommended that a qualified electrician determine the appropriate conductor size based on the specific requirements of your installation. Moving on to service upgrades, determining whether a service upgrade is necessary involves a few steps. Firstly, calculate the total amperage. This involves adding up the amperage of all the appliances and devices that will be connected to the circuit in the outbuilding. Secondly, consider future needs. Estimate any potential future electrical load increases, such as adding additional appliances or equipment to the outbuilding. Thirdly, compare this total to your service capacity. Check the amperage rating of your main service panel. If the calculated total amperage exceeds 80% of the panel's rating, a service upgrade may be required to prevent overloading and ensure safe operation. Finally, let's examine typical amperage readings for common appliances. A freezer typically draws between 3 and 5 amps. An air compressor can draw significantly more, typically between 12 and 15 amps. An 8-foot shop light typically draws between 1 and 2 amps. Standard power outlets usually draw between 1 and 2 amps per outlet, assuming typical appliances are connected. Remember that these are approximate values, and the actual amperage draw can vary depending on the specific appliance and operating conditions. If the total amperage draw exceeds the capacity of the circuit breaker, an upgrade may be necessary to prevent tripping and ensure safe operation. Remember, it is crucial to consult with a qualified electrician for all electrical work to ensure compliance with local codes and safe installation practices. Ignoring electrical codes can result in dangerous conditions, damage to equipment, or electrical fires. Here's a more detailed breakdown of key considerations for your outbuilding electrical setup. Firstly, circuit planning. Careful circuit planning is essential to prevent overloading circuits and ensure that each appliance receives the power it needs. Consider the specific power requirements of each device you plan to use in the outbuilding. Secondly, ground fault circuit interrupters or GFCI protection. Install ground fault circuit interrupters, GFCI, outlets in damp or wet locations, such as outdoor outlets or those near washer sources. GFCI outlets can help prevent electrical shocks. Thirdly, proper grounding. Ensure that the outbuilding is properly grounded to protect against electrical faults and ensure the safety of anyone using the electrical system. Fourthly, conduit. Protect wiring by running it through conduit, especially in areas where it could be exposed to physical damage. This is especially important for underground wiring. Fifthly, weatherproof enclosures. Use weatherproof enclosures for outdoor outlets, switches, and lights to protect them from the elements. Sixthly, surge protection. Consider installing surge protection to protect sensitive electronic equipment from voltage spikes. Seventhly, local codes and permits. Always check with your local building department to determine if any permits are required for electrical work and to ensure that your work complies with local codes. Eighthly, professional inspection. Have a qualified electrician inspect your work to ensure that it is safe and meets all applicable codes. Now let's delve deeper into conductor sizing. Conductor sizing is not just about the amperage draw of the appliances. It also involves considering voltage drop, which is the reduction in voltage that occurs as electricity travels along a conductor. Excessive voltage drop can cause appliances to operate inefficiently or even fail. The NEC provides guidelines for conductor sizing to limit voltage drop to acceptable levels. Factors that affect voltage drop include conductor length, conductor material, and the amount of current flowing through the conductor. Longer conductors, conductors with higher resistance, and higher currents all contribute to increased voltage drop. When selecting conductors, it's important to choose a size that will minimize voltage drop and ensure that appliances receive the proper voltage. The NEC provides tables that specify the allowable ampacity of different conductor sizes based on factors such as conductor material, insulation type, and installation method. These tables can be found in NEC Table 310.15, formerly NEC Table 310.16, and related tables. It's important to consult these tables when selecting conductors to ensure that they are properly sized for the intended application. Now, let's explore the process of calculating the total amperage for your outbuilding. This involves adding up the amperage of all the appliances and devices that will be connected to the circuit. To do this accurately, you'll need to know the amperage draw of each device. This information is typically found on the appliance's nameplate or in the owner's manual. For devices that don't list the amperage directly, you can calculate it using the formula amps equals watts divided by volts. For example, if an appliance is rated at 1200 watts and operates on 120 volts, the amperage draw would be 1200 watts divided by 120 volts equals 10 amps. Once you've determined the amperage draw of each device, add them all together to get the total amperage. It's also a good idea to add a safety margin of 20% to account for any potential future load increases. For example, if the total amperage of all the devices is 15 amps, adding a 20% safety margin would result in a total of 15 amps times 1.20 equals 18 amps. This will help ensure that your electrical system is not overloaded and can handle any potential future load increases. Remember, it's always better to err on the side of caution when it comes to electrical safety. Finally, let's discuss the importance of consulting with a qualified electrician. Electrical work can be dangerous and should only be performed by someone who is properly trained and licensed. A qualified electrician can assess your specific needs, recommend the appropriate wiring and components, and ensure that the work is performed safely and in compliance with all applicable codes. Attempting to perform electrical work yourself without the necessary knowledge and experience can result in serious injury or property damage. In addition to ensuring safety, a qualified electrician can also help you save money in the long run by preventing costly mistakes and ensuring that your electrical system is properly installed and maintained. They can also help you identify any potential problems before they become major issues. When choosing an electrician, it's important to select someone who is licensed, insured, and experienced in the type of work you need done. Ask for references and check online reviews to get a sense of their reputation and quality of work. A good electrician will be able to answer your questions clearly and provide you with a detailed estimate of the cost of the work. They should also be willing to explain the different options available to you and help you choose the best solution for your needs. In summary, planning the electrical for an outbuilding involves careful consideration of circuit layout, conductor sizing, service upgrades, and amperage readings. It's crucial to consult with a qualified electrician to ensure that the work is performed safely and in compliance with all applicable codes. Remember, electrical safety is paramount, and it's always better to err on the side of caution when it comes to electrical work. If the total amperage exceeds 80% of the panel's rating, it doesn't automatically mean you need to upgrade the panel. It indicates that the load is approaching the panel's capacity and warrants further investigation. Several factors should be considered. Firstly, demand factors. Not all appliances will be running at their maximum amperage simultaneously. Demand factors allow you to reduce the calculated load based on the likelihood of simultaneous operation. The NEC provides demand factors for various types of loads. Secondly, load diversity. Similar to demand factors, load diversity recognizes that different loads have different usage patterns. Some loads may be used more frequently than others, and some may only be used for short periods. Thirdly, existing load. If the existing load in the panel is low, there may be sufficient capacity to accommodate the new outbuilding load without upgrading the panel. It's essential to accurately assess the existing load before making any decisions. Fourthly, future expansion. If you anticipate adding more loads in the future, it's wise to consider upgrading the panel to provide ample capacity. Fifthly, panel rating. The panel's rating is not the only factor to consider. The service entrance conductors and the meter must also be sized to handle the load. Upgrading the panel without upgrading the service entrance conductors may not provide any additional capacity. In some cases, energy-efficient appliances can significantly reduce the overall load on the electrical system. Consider using energy-efficient lighting, appliances, and equipment in the outbuilding to minimize the amperage draw. Before making any decisions about upgrading the panel, it's essential to perform a load calculation in accordance with the NEC. This will provide you with a more accurate assessment of the load and help you determine whether an upgrade is necessary. The NEC provides specific guidelines for calculating loads for various types of occupancies and equipment. A qualified electrician can perform a load calculation for you and provide you with recommendations based on your specific needs. In addition to load calculations, it's also essential to consider the voltage drop when sizing conductors for the outbuilding. Voltage drop can cause appliances to operate inefficiently or even fail. The NEC provides guidelines for limiting voltage drop to acceptable levels. Longer conductors, smaller conductors, and higher currents all contribute to increased voltage drop. When selecting conductors, it's essential to choose a size that will minimize voltage drop and ensure that appliances receive the proper voltage. Using aluminum conductors instead of copper conductors can sometimes be a cost-effective way to reduce the cost of the wiring. However, aluminum conductors have a higher resistance than copper conductors, so they must be sized larger to carry the same amount of current. When using aluminum conductors, it's essential to use connectors that are specifically designed for aluminum conductors to prevent corrosion and ensure a reliable connection. In addition to the main panel in the house, you're planning to install a subpanel in the outbuilding. This is a good practice, as it allows you to distribute the electrical load more evenly and provides a convenient location for circuit breakers. When installing a subpanel, it's essential to follow the NEC guidelines for grounding and bonding. The neutral conductor must be isolated from the ground conductor in the subpanel, and a separate grounding conductor must be run from the subpanel to the main panel. This helps to prevent ground loops and ensure that the electrical system is properly grounded. The size of the subpanel should be based on the anticipated load in the outbuilding. It's always better to install a subpanel that is slightly larger than necessary to allow for future expansion. When selecting circuit breakers for the subpanel, it's essential to choose breakers that are rated for the voltage and amperage of the circuits they will be protecting. It's also important to choose breakers that are compatible with the subpanel. In addition to the general-purpose circuits for lighting and receptacles, you're also planning to install a dedicated circuit for the air compressor. This is a good practice, as air compressors can draw a significant amount of current and can overload the general-purpose circuit. The dedicated circuit for the air compressor should be sized to handle the compressor's maximum amperage draw. It's also a good idea to install a time delay fuse or circuit breaker on the air compressor circuit to prevent nuisance tripping. When wiring the air compressor, it's essential to use the correct size and type of wire. The wire size should be based on the compressor's amperage draw and the length of the circuit. The wire type should be suitable for the environment in which it will be installed. The wiring should also be protected from physical damage. In addition to the air compressor, you're also planning to install a freezer in the outbuilding. Freezers can also draw a significant amount of current, so it's essential to size the circuit accordingly. The freezer should be connected to a dedicated circuit to prevent it from overloading a general-purpose circuit. The freezer circuit should also be protected by a ground fault circuit interrupter, GFCI, to prevent electrical shock. When wiring the freezer, it's essential to use the correct size and type of wire. The wire size should be based on the freezer's amperage draw and the length of the circuit. The wire type should be suitable for the environment in which it will be installed. The wiring should also be protected from physical damage. Finally, let's discuss the importance of regular maintenance of the electrical system in the outbuilding. Regular maintenance can help to prevent problems and ensure that the system operates safely and efficiently. Maintenance tasks should include checking the circuit breakers for proper operation, inspecting the wiring for damage, and testing the ground fault circuit interrupters (GFCI). It's also a good idea to have a qualified electrician inspect the electrical system periodically to identify any potential problems before they become major issues. Regular maintenance can help to extend the life of the electrical system and prevent costly repairs. By following these guidelines, you can ensure that the electrical system in your outbuilding is safe, reliable, and efficient. Always remember to consult with a qualified electrician for any electrical work and to follow all applicable codes and regulations.